Short-run behavior intercepts. As with any function, we can find the vertical intercepts of a quadratic by evaluating the function at an input of 0, and we can find the horizontal intercepts by solving for when the output will be 0. Notice that depending upon the location of the graph, we might have 0, 1, or 2 horizontal intercepts. Example 7. Find the vertical and horizontal intercepts of the quadratic. F of x equals 3x squared plus 5x minus 2. We can find the vertical intercept by evaluating the function at an input of 0. F of 0 equals 3 multiplied by 0 squared plus 5 multiplied by 0 minus 2 equals negative 2. Vertical intercept at 0, negative 2. For those horizontal intercepts, we solve for when the output will be 0. 0 equals 3x squared plus 5x minus 2. In this case, the quadratic can be factored easily, providing the simplest method for solution. 0 equals 3x minus 1 multiplied by x plus 2. 0 equals 3x minus 1, or 0 equals x plus 2. X equals 1/3, or x equals negative 2. Horizontal intercepts at 1/3, 0, and negative 2, 0. Notice that in the standard form of a quadratic, the constant term c reveals the vertical intercept of the graph. Example 8. Find the horizontal intercepts of the quadratic f of x equals 2x squared plus 4x minus 4. Again, we will solve for when the output will be 0. 0 equals 2x squared plus 4x minus 4. Since the quadratic is not easily factorable in this case, we can solve for the intercepts by first rewriting the quadratic into transformation form. H equals negative b divided by 2a equals negative 4 divided by 2 multiplied by 2 equals negative 1. K equals f of negative 1 equals 2 multiplied by negative 1 squared plus 4 multiplied by negative 1 minus 4 equals negative 6. F of x equals 2 multiplied by x plus 1 squared minus 6. Now we can solve for when the output will be 0. 0 equals 2 multiplied by x plus 1 squared minus 6. 6 equals 2 multiplied by x plus 1 squared. 3 equals x plus 1 squared. X plus 1 equals plus or minus the square root of 3. X equals negative 1 plus or minus the square root of 3. The graph has horizontal intercepts at negative 1, minus square root of 3, 0, and negative 1 plus square root of 3, 0. Try it now. In Try It Now problem 2, we found the standard and transformation form for the function g of x equals 13 plus x squared minus 6x. Now find the vertical and horizontal intercepts, if any. The process in the last example is done commonly enough that sometimes people find it easier to solve the problem once in general and remember the formula for the result. Rather than repeating the process each time, based on our previous work, we showed that any quadratic in standard form can be written into transformation form. F of x equals a multiplied by x plus b divided by 2a squared plus c minus b squared divided by 4a. Solving for the horizontal intercepts using this general equation gives 0 equals a multiplied by x plus b divided by 2a squared plus c minus b squared divided by 4a. Start to solve for x by moving the constants to the other side. B squared divided by 4a minus c equals a multiplied by x plus b divided by 2a squared. Divide both sides by a. B squared divided by 4a squared minus c divided by a equals x plus b divided by 2a squared. Find a common denominator to combine fractions. B squared divided by 4a squared minus 4ac divided by 4a squared equals x plus b divided by 2a squared. Combine the fractions on the left side of the equation. B squared minus 4ac divided by 4a squared equals x plus b divided by 2a squared. Take the square root of both sides, plus or minus square root b squared minus 4ac divided by 4a squared equals x plus b divided by 2a. Subtract b over 2a from both sides. Negative b divided by 2a plus or minus square root of b squared minus 4ac divided by 2a equals x. Combining the fractions, x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Notice that this can yield two different answers for x. Quadratic formula. For a quadratic function given in standard form, f of x equals ax squared plus bx plus c, the quadratic formula gives the horizontal intercepts of the graph of this function. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Example 9. A ball is thrown upwards from the top of a 40-foot tall building at a speed of 80 feet per second. The ball's height above ground can be modeled by the equation. H of t equals negative 16t squared plus 80t plus 40. What is the maximum height of the ball? When does the ball hit the ground? To find the maximum height of the ball, we would need to know the vertex of the quadratic. H equals negative 80 divided by 2 multiplied by negative 16 equals 80 divided by 32 equals 5 halves. K equals h of 5 divided by 2 equals negative 16 multiplied by 5 divided by 2 squared equals 80 multiplied by 5 divided by 2 plus 40 equals 140. The ball reaches a maximum height of 140 feet after 2.5 seconds. To find when the ball hits the ground, we need to determine when the height is 0, when h of t equals 0. While we can do this using the transformation form of the quadratic, we can also use the quadratic formula. T equals negative 80 plus or minus square root of 80 squared minus 4 multiplied by negative 16 multiplied by 40 divided by 2 multiplied by negative 16 equals negative 80 plus or minus the square root of 8,960 divided by negative 32. Since the square root does not simplify nicely, we can use a calculator to approximate the values of the solutions. T equals negative 80 minus the square root of 8,960 divided by negative 32 is approximately 5.458, or T equals negative 80 plus the square root of 8,960 divided by negative 32 is approximately negative 0.458. The second answer is outside the reasonable domain of our model, so we conclude the ball will hit the ground after about 5.458 seconds.